In this example, I drive 120 kilometers to Ottawa at a certain speed, but on the way back I drive 20 kilometers per hour slower. If getting home takes 0.2 hours longer, what was my speed on the way there? This is the problem where two things change. And the first step to solving a problem like this is to identify the two things that changed along with their units. In this case, the two things that changed were the speed and the amount of time it took to do the drive. So I'm going to identify those two things here. My speed changed, I'm going 20 kilometers per hour slower on the way back, and the time it takes changed. It takes 0.2 hours longer on the way back. The next thing to do is to look at the question at the end of your problem. That question will ask you for one of the things that changed. And we use this to define our variables in terms of x. In this case, the question at the end is asking me for the speed on the way there. So I define x as my speed on the way there, and therefore x minus 20 will be my speed on the way home. The equation will have a shape like this. Fraction minus fraction equals difference. The other thing that changed, the 0.2 hours longer, goes right here to the right of the equal sign, if we are making our equation in the form of a subtraction. And the unit of this second thing that changed is hours. So basically what we have to do with our information is we have to convert each of these fractions so that its unit will be hours. Distance divided by speed equals time. So if I take the distance, 120 kilometers, and put it in the numerator of both fractions, and then if I put the speed in the denominator of both fractions, I am converting each fraction to have the unit of time. Distance divided by speed equals time in hours. Whenever I am building my equation in this way, if I have defined my variables so that I have x and x minus something, the x minus something binomial will go in the first fraction. This equation will solve our problem. It has a number of hours minus another number of hours equals the difference in the time it took. The question arises though, what if I had defined my variables differently? What if I had defined x as the speed on the way home, and x plus 20 as the speed on the way there? In this case, I have a binomial x plus 20 instead of the binomial x minus 20 involved. And when I build my equation, it's going to look like this. Again, the distance 120 goes in the numerator, and the x plus 20 and the x will go in the denominators, but I'm going to need to put x plus 20 over here and x in this fraction on the left if I want my equation to work. The reason for this is that in the first equation, x minus 20 is a smaller number than x. It has to be. And dividing the same value, 120, by a smaller number will give a bigger answer. It makes sense, therefore, that the bigger fraction is here, goes before the minus sign, and the smaller fraction will be after the minus sign, thereby giving us a positive answer. That will make sense. When we have x and x plus 20 instead, x plus 20 is bigger than x. So therefore, I divide 120 by the smaller number x, it gives me a bigger answer. I have the bigger number before the minus sign, and my subtraction will make sense. The first thing I'm going to do is build my equation and leave a bit of extra room, spreading things out, because I have to multiply each of the terms in the equation by certain values. Because my variables are in the denominators, I want to eliminate the fractions here, and I'll do that by multiplying each of the numerators and the 0.2 on the other side of the equals by both x minus 20 and x. It will look like this. Now, as I multiply, the x minus 20 over here on the top and the bottom is going to cancel. And in the second fraction, the x on both top and bottom is also going to cancel. So as I multiply, the left side starts looking a little bit less complicated. I have 120 times x for the first fraction, that gives me 120x, then my minus sign. Then I'm going to show the multiplication across this bracket inside a bracket. 120 times x is 120x, and 120 times negative 20 is negative 2400. The 0.2 is multiplied by both the x and the x minus 20, and I'm going to do this in stages. 0.2 times x, of course, is 0.2x. In my next step, taking away the bracket, I have minus 120x and now plus 2400 on the left side of the equals. And 0.2x times x is 0.2x squared. 0.2x times negative 20 is minus 4x. This 120x minus 120x, of course, will also cancel. And I'm going to move the 2400 to the other side of the equals. My equation ends up looking like this. 0 equals 0.2x squared minus 4x minus 2400. So we can now see that the building of this equation with all of its complicated steps was just an excuse to give us a quadratic equation. And we are going to solve for the zeros of the quadratic equation using the quadratic formula. I find my a, my b, and my c, and then I calculate my delta, which in this case is 1936. Plugging these values into the quadratic equation, I end up with the two answers, 120 and minus 100. In every case where I do a problem like this, I will throw away the negative answer, and the positive answer must be what I defined my x as in the beginning. Of course, I defined my x in the beginning as my speed on the way there. Therefore, my final answer is my speed on the way there was 120 kilometers per hour. I had defined my speed on the way back as x minus 20, so therefore my speed on the way back is 120 minus 20, or 100 kilometers an hour. Of course, that's the same value as I have in my negative answer that I threw away. This always happens as well. It is a long and complicated process to solve the problem where two things change. But it is easier to remember how to do it if we have the insight that really this is just an excuse to help us build a quadratic equation, and we are going to solve for the zeros.